Here, you have to integrate sec x upon under root of cos 2x. First of all, in numerator we have x as an angle, and in denominator we have 2x as an angle. So let's try to get same angle in numerator as well as denominator. So sec x will be as it is. Let's convert this cos 2x into cos square x minus sin square x. Now, here we have cos square minus sin square form. And to solve this, let's divide cos x in numerator as well as denominator. So here divided by cos x and here divided by cos x. If it go within the under root, it will become cos square. So in numerator, sec x upon cos x will give us sec square x, and within the under root, we have to divide cos square. So here we'll get 1 minus sin square upon cos square will be tan square x. We already have differentiation of tan x within the multiplication of dx. So we can assume tan x is equal to t. And if we differentiate both the sides, we will get sec square x dx as a dt. So our integration will be modified as sec square x dx will become dt, and 1 upon under root of 1 minus tan square x will become t square. Now we are ready to integrate. Integration of 1 upon under root of 1 minus t square is sine inverse t plus c. Now to get the final answer, just substitute the value of t, which is tan x. So we get sine inverse tan x plus c as your final answer, which is given in option A. Ta-da! Here we have to integrate 1 plus cot square x upon 1 plus cot x dot dx. Now we know that 1 plus cot square x is cos x square x, which is actually differentiation of cot x, which is given in denominator. So it suggests that we should assume 1 plus cot x is equal to t. So if we differentiate both the sides, differentiation of 1 will be 0 and differentiation of cot x will be minus cos x square x dot dx is equal to dt. So we can ignore this 0 and take this minus on the right side. So we will get cos x square dx is equal to minus dt. So we are ready to modify our integration. Cos x square x dx will give us minus dt, and 1 upon 1 plus cot x is converted into t. So we don't have to worry about this negative side. We just have to integrate 1 upon t, which is log mod t plus c. Or to get the final answer, just substitute the value of t, which is 1 plus cot x plus c is your final answer, which is given option A. Ta-da! Here we have to integrate 3x square upon x raised to 6 plus 1. Here in numerator we have 3x square, which is differentiation of x cube. So it suggests that we have to assume x cube is equal to t. So after differentiating, we will get 3x square dot dx is equal to dt. So our integration will be modified as this 3x square dx will become dt, and 1 upon x raised to 6 will become t square plus 1. So integration of 1 upon t square plus 1 is simply tan inverse of t plus c. Just substitute the value of t to get the final answer. So here we get tan inverse x cube as your final answer. Ta-da! Here, you have to integrate sin x cos x upon a cos square x plus b sin square x. Here, in denominator, we have a cos square x plus b sin square x plus c form, where c is 0. And in numerator, we have sin x cos x, which is actually differentiation of cos square x as well as sin square x. So, it suggests that we have to assume a cos square x plus b sin square x is equal to t. If we differentiate both the sides, we will get a as it is. Differentiation of cos square x will be 2 cos x into differentiation of cos x, which is minus sin x, plus b will as it is. Differentiation of sin square x will be 2 sin x into differentiation of sin x, which is cos x, dot dx is equal to dt. So let's take 2 sin x cos x common. So we will get b minus a dot dx is equal to dt, or we can say sin x cos x dot dx is simply 1 upon 2 b minus a dot dt. So we are ready to modify our integration. This sin x cos x dot dx will become 1 upon 2 b minus a dot dt, and 1 upon a cos square x plus b sin square x will become your t. So we don't have to worry about this 2b minus a. It's a constant. We just have to integrate 1 upon t. So let's rewrite 1 upon 2b minus a as it is, and integration of 1 upon t is simply log mod t plus c. And to get the final answer, we just have to substitute the value of t. So log mod a cos square x plus b sin square x plus c is the final answer, which is given in option A. Ta-da! Here, you have to integrate x into x raised to x into 2 log x plus 1. Here, this x raised to x can be rewritten as x raised to x square. So, let's assume x raised to x square is equal to t. Now, on left side, we have variable raised to variable. So for that, we have to take log on both sides. So on left side, we will get log of x raised to x square. And on right side, we will get log of t. So before we go for differentiation, let's apply property of log. And according to property, we can take this x square within the multiplication of log. So we will get x square log x is equal to log t. Now we are ready for differentiation. On left side, we have to apply multiplication rule. Let's say x square is as it is, differentiation of log x is 1 upon x plus log x is as it is, differentiation of x square is 2x dot dx is equal to differentiation of log t will be 1 upon t dot dt. In simplification, we can say this x will cancel out and we can take x common. So here we'll get 1 plus 2 log x dot dx is equal to 1 upon t dot dt. So we are ready to modify our integration. This x into 2 log x plus 1 dot dx will become your 1 upon t dot dt, and x raised to x square is your t. So here dt will cancel out. We just have to integrate 1 with respect to t. Integration of 1 with respect to t will be t plus c. And to get the final answer, just substitute the value of t, which is x raised to x square, or we can say x raised to x whole raised to x plus c, which is given in option A. Ta-da! Here we have to integrate x cube upon 1 plus x raised to 8. In numerator, we have x cube, which is differentiation of x raised to 4. So we should assume x raised to 4 equal to t. Let's differentiate both the sides. We will get 4x cube dot dx is equal to dt. So if we modify our integration, instead of x cube dot dx, we have to write down dt by 4. 1 upon 1 plus x raised to 8 will become t square. So we don't have to worry about this 1 by 4. Integration of 1 upon 1 plus t square is simply tan inverse of t plus c. And to get the final answer, just substitute the value of t, which is x raised to 4 plus c. So 1 by 4 tan inverse x raised to 4 plus c is your final answer, which is given in option B. Ta-da! In this question, we have to integrate e raised to x upon under root of 1 minus e raised to 2x. In numerator, we have e raised to x, and in denominator, we have function of e raised to x, which suggests that we have to assume e raised to x is equal to t. So we will get e raised to x dot dx is equal to dt. So we are ready to modify our integration. This e raised to x dot dx will become your dt, and 1 upon under root of 1 minus e raised to 2x will become t square. Now we have to integrate 1 upon under root of 1 minus t square, and answer must be in terms of cos inverse. So integration of 1 upon under root of 1 minus t square is simply minus cos inverse of t plus c. And to get the final answer, we just have to substitute the value of t, which is e raised to x plus c. So minus cos inverse of e raised to x is your final answer, which is given in option B. Ta-da! Here we have to integrate a raised to x plus tan inverse x into x square plus 2 upon x square plus 1 dot dx. As you can see, x tan inverse x is an inner function, and differentiation of tan inverse x is available 1 upon x square plus 1. So let's try to simplify our integration by assuming x plus tan inverse x is equal to t. So if we differentiate both the sides, we will get differentiation of x will be 1 and differentiation of tan inverse x will be 1 upon 1 plus x square dot dx is equal to differentiation of t. This will be dt. If we simplify this, you have to take LCM. 1 plus x square 1 is 1 plus x square plus 1 will give us 2 plus x square upon 1 plus x square dot dx is equal to dt. So we are ready to modify our integration. A raised to x tan inverse x will become your t, and x square plus 2 upon x square plus 1 dot dx will become your dt. So we just have to integrate a raised to t upon log a plus c. And to get the final answer, just substitute the value of t, which is x plus tan inverse x. So here we get a raised to x plus tan inverse x upon log a plus c as a final answer, which is given in option C. Ta-da! Here we have integration of fx is equal to fx. Then we have to find integration of fx square. First of all, you should note that integration of function is equal to itself, which suggests that our function must be equal to e raised to x, because e raised to x is the only function which satisfies this condition. Now, we have to find integration of fx the whole square, or we can say we have to integrate e raised to x the whole square dot dx, which can be rewrite as e raised to 2x. Its integration will be e raised to 2x upon coefficient of x, which is 2, plus c. Now let's rearrange, or we can say simplify e raised to x the whole square plus c. So we can say this is nothing but f of x the whole square plus c by 2. Here's your final answer, which is option 2. Ta-da! Here we have to integrate log x plus under root of 1 plus x square upon under root of 1 plus x square. Here in numerator we have log of x plus under root of 1 plus x square, which is actually integration of 1 upon under root of 1 plus x square. So we can say differentiation of log of x plus under root of 1 plus x square is 1 upon under root of 1 plus x square. It suggests that we have to assume log of x plus under root of 1 plus x square as a t. So if we differentiate both the sides, on left hand side, we have to consider log is the outermost function. So we have to consider box around the rest of the function. So 1 upon box into d by dx of box. And within the box, we have x plus under root of 1 plus x square. So differentiation of x will be 1 plus differentiation of root box will be 1 upon 2 root box into d by dx of box. Within the box, we have 1 plus x square. So we just have to multiply differentiation of 1 plus x square, which will be 0 plus 2x is equal to differentiation of t will be dt. So in simplification, your first term will be as it is, and in second bracket 2 will cancel out, and we can take LCM of under root of 1 plus x square. So it will give us under root of 1 plus x square plus x upon under root of 1 plus x square dot dx is equal to dt. So x plus under root of 1 plus x square, x plus under root of 1 plus x square will cancel out, and we will get 1 upon under root of 1 plus x square dot dx is equal to dt. So we are ready to modify our integration. Instead of log x plus under root of 1 plus x square, we can say we have t, and 1 upon under root of 1 plus x square dot dx will be your dt. So we just have to integrate t, which will be t square by 2 plus c. And to get the final answer, we just have to put this value of t, which is log mod x plus under root of 1 plus x square the whole square by 2 plus c. The final answer, which is given in option A. Ta-da! Here we have to integrate cos x square into x dot dx. X square is an inner function and its differentiation is already available. So simply assume x square is equal to t. Differentiate both the sides, we will get 2x dx as your dt. We already have x dot dx. So let's take 2 on the right side. Will give us 1 upon 2. So we are ready to modify our integration. This cos x square will become your t, and this x dot dx will become 1 by 2 dot dt. So we don't have to worry about this 1 by 2. Just integrate cos t, which is sin t plus c. Just substitute the value of t to get the final answer, which is x square plus c. So 1 by 2 sin x square plus c is your final answer, which is given in option D. Ta-da! Here we have to integrate sin inverse x upon under root of 1 minus x square. As you can see, we have differentiation of sin inverse x within the multiplication of dx. So we have to assume sin is equal to t. Differentiate both the sides, we will get 1 upon under root of 1 minus x square dot dx as your dt. So we can modify our integration as, instead of sin inverse x, we can put t, and instead of 1 upon under root of 1 minus x square dot dx, we can substitute dt. So integration of t will be t square by 2 plus c, and to get the final answer, just substitute the value of t, which is sin inverse x, the whole square by 2 plus c. Is your final answer, which is given in option B. Ta-da! Here we have to integrate 1 upon x minus root x, or we can say here we have x raised to 1, x raised to 1 by 2, which is in the form of 1 upon x raised to 1 upon p plus x raised to 1 upon q form, where p is less than q. So in this in this case, we have to take x raised to 1 upon q common. So let's take 1 upon x raised to 1 by 2 common. So we will get 1 upon x raised to 1 by 2 minus 1 dot dx. Now, in second step, we have to assume this x raised to 1 by 2 minus 1 is equal to t. So let's assume x raised to 1 by 2 minus 1 is equal to t. If we differentiate both the sides, we will get 1 by 2 x raised to minus 1 by 2 minus 0 dot dx is equal to dt. Or we can say 1 upon root x, 1 upon x raised to 1 by 2 dot dx is equal to 2 times dt. Okay? So if we rearrange the term, or we can say let's write down this 1 upon x raised to 1 by 2 with dx, we can easily modify our integration as 1 upon this x raised to 1 by 2 minus 1 is simply your t, and this 1 upon x raised to 1 by 2 dot dx is simply 2 dot dt. So we don't have to worry about this 2. Just integrate 1 upon t, which will be log mod t plus c. And to get the final answer, just substitute the value of t, which is x raised to 1 by 2 minus 1 plus c, or We can rewrite as 2 log mod root x minus 1 plus c is your final answer, which is given in option A. Ta-da! Here you have to integrate 1 plus log x upon 1 plus x log x the whole square. In numerator, we have 1 plus log x, which is differentiation of x log x. So it suggests that we have to assume 1 plus x log x is equal to t. So let's differentiate both sides. Differentiation of 1 will be 0 plus, here we have to apply multiplication rule. Let's say x as it is. Differentiation of log x is 1 by x plus log x will be as it is. Differentiation of x will be 1 dot dx is equal to differentiation of t will be dt. So here we get x squared 1 plus log x dot dx is equal to dt. So we are ready to modify our integration. This 1 plus log x dot dx will be your dt, and 1 upon box square is simply t square, or we can say we have to integrate t raised to minus 2, which will be t raised to minus 1 upon minus 1 plus c. We can rewrite as minus 1 upon t plus c. And to get the final answer, we just have to substitute the value of t, which is 1 plus x log x plus c. So we can say minus 1 upon 1 plus x log x plus c is your final answer, which is given in option C. Ta-da! Here we have to integrate x raised to n minus 1 upon x raised to 2n plus a square. In numerator, we have x raised to n minus 1, which is differentiation of x raised to n. So let's take x raised to n is equal to t. So we will get n x raised to n minus 1 dot dx is equal to dt. We have x raised to n minus 1 dot dx. So let's take this n on the right side. We will get 1 upon n dot dt. So we are ready to modify our integration. This x raised to n minus 1 dot dx will become your 1 upon n dot dt, and 1 upon x raised to 2n will be t square plus a square will be as it is. We don't have to worry about this 1 upon n. 1 upon a tan inverse of t by a plus c. So 1 upon a into n is as it is. We just have to substitute the value of t, which is x raised to n upon a plus c is your final answer. Option A. Ta-da!